Alright, hey, it's Coach Boyett, and this is the video over alpha decay. We talked about the three different particles, alpha, beta, and gamma, and that's my 3-year-old daughter in the background talking to me. She's trying to help, so sorry about that. Alright, so alpha decay. Alpha decay is this right here. It's all atoms with more than 83 protons decay by themselves, which means this. Basically, remember we talked about this, every time you add more and more protons, they're all positively charged. Yeah, you're adding more neutrons, but once you finally get to a certain point, which seems to be around 83 protons, what starts to happen is there's just too many protons. They're all positively charged. They're all trying to push each other apart. And so what happens is when you get more than 83, they automatically start trying to push themselves out. It's kind of like being on a little small dance floor, and there's just too many people. People obviously start to get pushed off to the side and can't be on the dance floor anymore. And that's kind of what happens when you get over 83 protons. They start to get pushed out. And so this is called alpha decay. And what happens is when they get pushed out in groups of two protons, and actually 2 neutrons at the same time get pushed out. So they don't just push out 1 proton or 1 neutron or anything like that. They push out 2 protons, 2 neutrons at the same time. And so what happens is this right here is a nuclear reaction equation. And so what happens most of the time in these kind of equations, they're going to give you 2 different things. You have to figure out what the last one is. And so basically what's going to happen here is polonium. This is PO, polonium. It has 84 protons, and its mass number is 210 mass units. And it's going to decay into lead, which has 82 protons and 206 mass units. So really, what you got to ask yourself when you see this is, what is the difference between these two things? Well, the difference between these two things is what? 2 protons. So I'm going to put 2 down here where the protons are. Protons are at the bottom. There's 2 of them. Up here, what's the difference between these two numbers? Well, it's 4. 206 and 4 gives you 210. So when you add 82 plus 2, you get 84. When you add 206 plus 4, you get 210. Now, this right here is actually something real. So I have to look on my periodic table and find out what it is. And so something that has the atomic number of 2 and a mass number of 4 is actually helium. And so that right there is actually an alpha particle that we've been talking about. This is an alpha particle. Now, you may see this written a different way. And alpha particles, sometimes people write them like this, where they actually write the letter alpha, and they'll put a 2 and a 4. But really, I mean, look at it. It's the same freaking thing, right? It's no big deal. It's the same thing. So don't let that confuse you. Now, I kind of messed up on this when I started to do this beforehand. But this is the same kind of problem. What they're going to do on this kind of problem is they're going to leave this blank, and they're going to give you the fact that you're having alpha decay that's going on here, and there's an alpha particle right here. And so all you got to do is the same thing. I have 88. This is radium. Radium has a atomic number of 88 and a mass number of 226. And so it's really simple. What plus 2 gives you 88? Well, 86 plus 2 gives you 88. And what plus 4 gives you 226? 222. So 222 plus 4 gives 226. 86 plus 2 gives 88. And so now, again, I look on my periodic table, and I find the atomic number of 86. And when I do that, I believe, let me click right here real quick. I believe, yep, it's radon, which is Rn. And so radon. And so really what you look is this. Alpha decay is whenever there's too many protons, they get crowded. Once you get over 83, you're trying to get rid of protons. And so when polonium gets rid of protons, it gets rid of it in 2. You want to say, you have the hiccups? You want to say hi to everybody? Say hi. She's shy. She doesn't want to say hi. So what happens is polonium gets rid of those 2 protons and turns into lead. Radium gets rid of 2 protons and turns into radon. Okay? So when you're working on that today, make sure you get that right.